Did you know that a 17th century Frenchman was a mathematician, physicist, inventor, and religious philosopher all in one? That's Blaise Pascal for you. Born in the early 17th century, Pascal was a prodigy who left his mark on a wide array of fields. His mathematical genius led him to devise Pascal's triangle, a mathematical marvel that's still taught in schools today. His inquisitive mind didn't stop at numbers though. Pascal was also a key figure in the world of physics, where he explored the principles of fluid mechanics, and even laid the groundwork for the invention of the hydraulic press. Not just a man of science, Pascal was deeply religious, and his philosophical writings, notably his Pensées, have resonated through the centuries. A thinker, a scientist, a philosopher, Blaise Pascal was truly a man ahead of his time. So let's embark on a journey through the life of this intellectual giant. Imagine being a teenager and making a discovery that shapes the world of mathematics. That's exactly what Pascal did with his famous triangle. As a mere youth, Pascal stumbled upon a pattern of numbers that opened up a new dimension in the mathematical universe. This pattern, now known as Pascal's triangle, is a triangular array of binomial coefficients. It's the coefficients that give it its power, each one a building block in the world of probability theory. Picture a row of numbers, each one the sum of the two numbers directly above it. This simple rule generates the triangle, and with it, opens the door to a world of mathematical possibilities. From calculating combinations and permutations to exploring patterns in numbers, to even delving into the realms of algebra and geometry, Pascal's triangle is a true marvel. Pascal's triangle, a simple yet profound discovery, continues to be a fundamental tool in mathematics. What if you could use logic to decide on faith? Pascal did just that with his famous wager. Enter the world of Blaise Pascal, a 17th century philosopher who dared to intertwine faith and reason in a game of chance. Pascal's wager is simple yet profound. It poses the question, should one believe in God? Well, according to Pascal, the answer lies in the stakes. If you wager on God's existence and you're right, you gain infinite happiness. If you're wrong, you lose nothing. However, if you bet against God and you're wrong, you face infinite misery. But if you're right, you gain nothing. This intriguing argument is not so much about the existence of God, but rather about the rationality of belief. It's a daring blend of philosophy and probability, a gamble on the ultimate stakes. Pascal's wager challenges us to consider the potential outcomes of our beliefs, pushing the boundaries of philosophical thought. Pascal's wager, a daring mix of philosophy and probability, continues to ignite debates even today. Ever wondered why hydraulic systems work the way they do? Thank Pascal for that. Now let's dive into the fascinating world of fluid dynamics. Here's where Pascal's law comes into play. In simple terms, Pascal's law states that any change in pressure applied at any point in a confined, incompressible fluid is transmitted undiminished throughout the fluid. Imagine a water-filled balloon. Squeeze one part, and the rest of the balloon expands equally, right? That's Pascal's law in action. This principle is the driving force behind hydraulic systems. Think of car brakes, elevators, and even amusement park rides. All these utilize the power of Pascal's law. When a force is applied at one point, it's distributed evenly, allowing for smooth and efficient operations. Pascal's law has revolutionized our understanding of fluid mechanics and has found countless practical applications. It's one of the many examples of how Blaise Pascal's brilliance continues to influence our world today. Pascal's law, a cornerstone in fluid mechanics, is a testament to his scientific genius. In a time when computers were a distant dream, Pascal was already laying the groundwork. The 17th century was not exactly known for its technological advancements, yet, in this era, Blaise Pascal invented the Pascaline, a mechanical calculator that was centuries ahead of its time. Pascal was driven by a practical problem. His father, a tax collector, needed a more efficient way to crunch numbers. So, at just 19 years old, Pascal started designing the Pascaline. This remarkable device could add and subtract directly, and multiply and divide through repeated addition or subtraction. Though it wasn't perfect and it wasn't a commercial success, the Pascaline was a leap forward. It was the first mechanical calculator that was actually functional, setting the stage for the computational devices that would come centuries later. Pascal's calculator, a precursor to modern computers, shows us his visionary spirit. Beyond science and mathematics, Pascal also ventured into the realm of theology. His religious and philosophical ideas were compiled in a collection of thoughts and writings known as Pensées, or Thoughts. This unfinished manuscript, published posthumously, offers a compelling exploration of human nature, morality, and faith. Pascal's Pensées is a profound reflection on the human condition. He mused on life's paradoxes, the nature of faith, and the dichotomy of belief and skepticism. This work was not merely a theological discourse, but also a philosophical investigation into the human mind and spirit. Pascal contemplated the mysteries of existence, and his insights still resonate today. He touched upon the themes of human suffering, the quest for happiness, and the paradox of the finite in the infinite. He saw the human condition as a constant struggle, and yet he also saw faith as a beacon of hope amidst these existential crises. Pascal's Pensées, an introspection of faith and reason, reflects his deep spiritual insights. Pascal was not just about theory, he put his ideas to the test. When it came to the concept of a vacuum, Blaise Pascal was a true pioneer. He was determined to challenge the classical Aristotelian belief that nature abhors a vacuum. In the mid-17th century, Pascal conducted a series of experiments. He used a mercury barometer to demonstrate that atmospheric pressure decreases with altitude. This was a groundbreaking revelation. It proved that the space above the mercury was not filled with an invisible substance, as was widely believed, but was actually a vacuum. These experiments were not merely academic exercises for Pascal. They were an expression of his unquenchable curiosity about the natural world and his determination to challenge accepted wisdom. His findings laid the groundwork for the development of vacuum technology and the study of atmospheric pressure. Pascal's experiments with vacuums paved the way for future studies in atmospheric pressure. Pascal's life was short, but his impact is eternal. Blaise Pascal, a 17th-century polymath, left an indelible mark on the world, influencing a variety of fields from mathematics and science to philosophy and theology. In mathematics, Pascal's triangle, a simple yet revolutionary concept, continues to be a fundamental part of combinatory mathematics and probability theory. His work on projective geometry and conic sections has also proven to be invaluable, providing the foundation for many modern mathematical concepts. In the realm of science, Pascal's law, which describes how changes in pressure are transmitted equally in all directions in a fluid, is instrumental in fluid dynamics. It is used in a wide range of applications, from hydraulic brakes in vehicles to the understanding of blood circulation in our bodies. Pascal also ventured into the world of technology, designing and building one of the very first mechanical calculators. Known as the Pascaline, this early computer laid the groundwork for the development of modern computing technology. In philosophy, Pascal's wager, a thought-provoking argument about belief in God, continues to be a topic of intense debate among philosophers and theologians. His profound reflections on religion, captured in his posthumous work Pensées, offer deep insights into the human condition and our relationship with the divine. Pascal's experiments with vacuums further propelled scientific understanding of atmospheric pressure, paving the way for future advancements in thermodynamics and meteorology. Pascal's contributions were not confined to his lifetime. His innovative ideas and groundbreaking work continue to resonate, influencing modern science, mathematics, philosophy, and theology. His legacy is a testament to the power of curiosity, creativity, and intellect. Despite his short life, Pascal's work continues to be a beacon of knowledge, illuminating the path for future generations of thinkers and innovators. Blaise Pascal, a polymath who transcended boundaries, continues to inspire us with his enduring legacy.